Binomial factoring. The big thing that I want you guys to realize is the first step in all factoring is to look for a GCF. I already started. Good try though.
I don't know why, but when I see the look, it looks like 100.
Why is it?
Yeah, I don't see the L in look, I just see 100K.
It's like doubled, like.
Yeah, and like
It looks pretty. Why did you draw your stars like that?
shadow.
Why did you draw your
No.
stars like that? It looks weird.
Because I want to.
Yeah, it's like blue.
You usually don't. draw.
Okay, guys, please stop talking. Okay, so we are going to be looking for that GCF today and factoring by grouping. So first we need to factor out the GCF. Who can tell me what the GCF in both of these terms, so this is multiplication here and another multiplication here separated by subtraction. What is the GCF in number 1? Connor?
What? 2.
Not x4, but nope.
X plus 4.
Okay, Mike.
Prime.
Not prime. No, Tenari's.
X plus 4.
Okay, so I heard 2x. Does this one have a 2x to take out?
No.
No, I heard x. This one doesn't have an x right here to take out. But you'll notice that they share this parenthesis here of x plus 4.
What?
That is your GCF.
What?
So, that goes, that gets taken out. So if we divide by x plus 4, if we divide both by x plus 4, x plus 4 cancels out, and what do you have left there?
2x.
And x plus 4 cancels out, and you have?
Minus 3.
And there you go. You've just factored that problem.
What?
Okay, something wet.
So basically, you just take out the GCF.
This is easier than the first
What you
one.
have left.
That'll be harder. I'm just trying to get you started here. Okay, guys, please focus. Connor, I tried to hear your question, but there is so much talking. What did you just say?
So we basically you just take out like the GCF, put it down below, and then you take the last two numbers off.
Essentially, but we're going to have one more step going on to the next page, but I'm just starting you guys off on like the last step, so yeah. So what is the GCF of number 2 then, Josh?
So the GCF would be y minus 2.
They share the quantity y minus 2. So our GCF is y minus 2, which goes out front in parentheses. And then we divide both by y minus 2. So Riley, if you divide that first term by y minus 2, what is left over?
3y to the second power.
3y to the second power. RC, if you divide that second term by y minus 2, what do you get? Plus 5, and you are done.
I get it.
I'm doing.
Yeah, you're using photomath
I'm using
for your clever assignment. You can type anything into photomath. It has an option to let you type stuff in. All right, so Grace, what is the GCF of number 3? I bet you I'm the only one that heard that.
I heard it barely.
So the GCF is x minus 3. So that goes out front. Okay, why are you talking? Stop. Jana, what would the first term be if we divide by x minus 3? 4x. What would, Justin, the second term be if we divide by x minus 3? Did you tell him not to talk? He has to respond to me, though.
What are you asking?
What is x minus 3 divided by x minus 3?
X what?
This divided by this. It's 1. The same thing divided by itself is 1. There is technically a 1 out front here that you are distributing, so that's why that is the case. Okay, so what do you notice happened each time we factored out a GCF? Something that you guys noticed, Riley?
It was always in parentheses.
So the GCF was the same thing in the parentheses. Yeah, I did. What else did you know? What do you notice about the second one? What do you notice about the second piece?
It's like the front half of the.
It's what is multiplying by the parentheses, right?
Yeah.
Okay, so we are going to use this thought by factoring by grouping. What'd you say? Yolanda?
Yeah, I have to refer to me. To Yolanda.
You did turn in a assignment with Yolanda as your name, so. Okay, when you're ready, flip to the next page.
I'm legally changing my name to Yolanda.
That sounds like a lot of work.
Oh no.
So it's like this bit and this bit.
Here, I'll give you guys both the cake. Are you going to attack people with Did that like slip out of your hand?
I'm going to take carrots from you if you continue this.
I didn't mean to.
Okay, please stop talking. When factoring by grouping, whenever you see a 4-term polynomial, so whenever there's 4 terms, you are going to need to use factoring by grouping. So you are going to see at some point a diagram that says the first step is GCF. The second step, you're going to have to do something if it's 2 terms, 3 terms, or 4 terms. And the last thing you always do is look for a 2-term difference of squares. But if it's always 4 terms, you factor by grouping. So the first thing you need to do is make sure your polynomial is in standard form, which is the highest exponent to the lowest exponent. After you do that, you are going to group the first 2 terms together and the last 2 terms together using a parenthesis. Make sure you actually rewrite this. Don't be lazy and just put it on top, which is what some of you are going to do.
What do you mean put it on top?
You'll know what I mean in a second. Then you are going to factor out the GCF within both groupings separately. So you're going to do 2 different GCF problems. And then finally, you're going to finish the factoring out by factoring out what is in the parentheses, which is doing factoring a GCF again. Always, before you do anything, step 0, I'm going to call it, is look for a GCF. That's always the first thing you do in all factoring problems. Okay, we're going to get started here, get through some examples, and then I'll have you guys practice some. Okay, so first thing you need to do in any problem is look for a GCF. So is there a GCF that can be taken out of any of these ones?
No.
No, that does not make it prime. 3 cannot come out of it and 2 can't come out of it, and they all don't have an x. That is not prime because it has 4 terms we have to group. So the first 2 steps says to group to make sure it's in standard form. So is that in standard form?
Yeah.
Then we group the first 2 terms together. And we group the last 2 terms together. Do not just put this directly on top of the original problem. I realize you can do that, but it will make it better for you guys to have it separated. Can you stop? Seriously?
I'm eating my lunch.
Okay, that's great. You don't need to talk the whole entire time. So, Jordan Fields, what is my GCF in the first parenthesis? Because that's the next step. So what's the GCF of 3x cubed plus 3x squared? Yeah. So we take out a 3x to the second. And I divide each piece by 3x to the second. And Lexi, what is left in the parenthesis then? Good, and it's important you put that plus 1. So 3x to the third over 3x squared, 3 minus 1 leaves you with a single x. Same thing divided by the same thing as 1. Cassie, what is my GCF of 2x plus 2? So I take a 2 out and I divide everything by 2. Jayla, what's 2x, or so what goes in that parenthesis, I guess?
X plus 1.
X plus 1. 2x divided by 2 is x. 2 divided by 2 is 1. What do you notice about both those parentheses? They both have x plus 1. It looks like the problems we just did on the previous slide, right? So do you see this x plus 1 here? So that is our GCF that we are going to pull out. So we pull out the x plus 1, and we divide each of our pieces by x plus 1. So Emma, what's in that other parenthesis then? Be careful. 3x squared times x plus 1 divided by x plus 1 is just... Good, and then what's the next piece? Plus 2. I'm going to be clear that's the answer, just so you don't think any of the other steps in between are the answer. So make sure you have circled your actual answer, not the non-answer answers that you might think they are. Okay, last warning. Seriously. Okay, number 2. Number 2. Is there a GCF?
Yeah. No, what?
So 14, 2, 21, and 3 have something in common.
Oh, no.
No. Can you take any x's out?
No.
No, so we parentheses them up, which means you group them is another way to say that. So we group the first 2 together, and do not just do this on top of the problem. Don't be lazy. Rewrite it. And regroup the last part. Parentheses them up.
You should use that word. You should use that word.
Okay, Colin, what is the GCF in that first parenthesis there? 14x squared minus 2x. Continue. You have to look at the variables too. You can take a 2x out of both of them. So Justin Powers, what is left in the parenthesis then? So this has a 1 on it. 2 minus 1 is 1. Okay, then what's the next piece? Minus 1. Kaylee, what's my GCF of that second parenthesis there?
3.
Okay, and Jordan Coward, if I divide by 3 on both pieces, that becomes?
7, 1, right?
Not just 7 and 1. We have a little bit of missing there.
-1.
Okay, still missing something.
X.
Yes, it's 7x minus 1. You should now notice you are not done with the problem, but they share 7x minus 1, which is our GCF of that piece. So, Connor, Yolanda, what is left over if we're dividing by 7x minus 1 in both pieces? 2x plus 3. Now, there is a lot of work up here. I don't think you guys are going to need to show every single one of these steps to get to the answer, but I want you guys to realize where I'm coming from. So I'm going to kind of start taking some of that work away now, just so you're aware. Okay, Connor Clover, is there a GCF in 6x cubed minus 18x squared minus x plus 3 first? Is there any GCF involved in those four terms? What number can be pulled out of all of them? 3 doesn't come out of 1? No, there's not. So what do we do if there's no GCF and there's four terms? We group them. But wait! There's a negative here. You keep the negative with the variable. So you keep the negative with that variable or whatever term is right there. So I'm always going to make it addition, but the negative comes from here. Because can't you guys write this as plus a negative? Did you guys ever learn to do that when you first were learning to subtract?
Yeah.
So, I mean, that was back in middle school, so I don't know what you did then. All right, so we need a GCF, Blaine. What is the GCF of that first part?
-18.
You can take a negative 18 out of a 6?
Yes. I mean, 6.
Okay, 6x.
It's your third power.
So there's 3 x's to steal from this one?
First power.
But I can take more than that.
2.
6x squared. The most you can take from both of them is 2. So what would be left in the parentheses, Tanari?
X minus 3.
Good. So notice I didn't show the division this time, but all I did here is I did 6x cubed divided by 6x squared and got x. 18x squared divided by 6x squared and got 3. Tanari didn't need that there, and I don't know if you wrote it on your paper, but you guys can do some of these pieces in your head if you're able to. Mike, what do you think we take out of that second parenthesis? Because remember, we're trying to make it look the same as x minus 3. So what can we take out of it to make it look like x minus 3? I called on Mike. I'll call you if he needs help. What would make that look the same? What is the difference between these two? What's the difference between this and this and this and this? The terms are what? Opposite, negative of each other. So what can you, negative's fine. So what can you take out to make them the same sign? What can you multiply a negative by to make it a positive? So what can we factor out then? Negative 1. So if we divide both pieces by negative 1, that gets us to look the same. Do you guys see that?
Yeah.
So if there's ever that piece, those are just opposite signs. You just factor out that negative 1. So, Colin, what is my final answer then?
Okay,
What do you pull out? The GCF is?
6.
What's the GCF first?
Oh.
Not that it really matters that much, but pull out the GCF first.
X minus 3, and then,
Colin.
What?
Blaine, stop. Oh, I'm sorry, Connor. Sorry.
Wait.
I know. I was also yelling at Blaine as well, though. Blaine, guys, you two need to stop talking. Go ahead. Continue, Colin.
X minus 3, and then,
Stop. So you took these out, so you're dividing each of these pieces by x minus 3. So what is left over then? What you were saying before you started saying x minus 3.
oh, so then it's 6x minus 6x squared. And then minus 1.
There you go. And that is your answer. All right. Brian, is there a GCF involved in any of those pieces?
Miss Brady.
Hi, I'm teaching. X to what? Is there an X here to take?
Oh wait, no.
So is there a GCF at all? It's not prime, because what can we do if there's 4 terms? What have we been doing? What did we do if there was 4 terms? We grouped the first 2 terms and the second 2 terms. So we group x squared minus 7x. Remember that negative, we always make this plus a negative, so this becomes plus negative 3x plus 21 in parentheses. So Brian, what is the GCF of x squared minus 7x? X to the first. So Alyssa, what's left inside of that parenthesis then? Okay, Jordan, Files, what is the GCF of negative 3x plus 21? What goes into both 3 and 21? 7 goes into 3? 3. And it's important you take this out as a negative. We don't want that front number ever to be negative, so whenever it's negative, we take it out as 1. So what is left over if we're dividing by negative 3? And x. So, Justin Powers, what is my final answer then if they both share this x minus 7? When has my answer just been one number? Look at all my parentheses. I took out the GCF of x minus 1, or x plus 1 and put it in front. I took out the GCF of 7x minus 1 and I put it in front. I took out the GCF of x minus 3 and put it in front. What is the GCF you pull out here?
X minus 7.
And then what goes in the other parenthesis? There you go. Okay, again, stop talking. Let's go. We have a few more examples that I want to get through with you guys, and then I'm going to let you guys try a couple on your homework. I might skip a few here and there just so you guys can get your homework to practice it. All right. You will notice that 5 and 7 on here are not in what form? So let's rewrite these in standard form.
You're not an English teacher.
So, what is the number 5 in standard form? What is number 5 in standard form? Brian?
12x to the third minus 18x squared plus 10x minus 15.
Okay. Is there a GCF that we can take out of those 4 terms? No. So we factor by grouping because it has 4 terms. So we group the first 2 together. And we group the last 2 together. Jana, what is the GCF of 12x to the third minus 18x squared? Bigger.
6x to the second power.
Okay, so what's left in the parenthesis then?
2x and then 3.
Okay. Grace, what can I take out of 10x minus 15? And what's left in the parenthesis?
2x.
Okay, so we have the same thing in both parentheses there, so that's what we're going for.
Whoa.
So, Connor Yolanda, what is your final answer then?
6x squared plus 5.
What goes in front of that? What's the GCF that goes in front of that?
Oh, 2x minus 3.
Times?
And 6x squared plus 5.
Yep, you take the GCF out, and then you put that in front. Technically, the order does not matter because multiplication is commutative, but I want you guys to get used to that. Just knowing why that's in front. Okay, the next one there is not in standard form. The next one there is not in standard form either. So RC, put number 7 in standard form. I'm skipping number 6. Okay, is there a GCF we can pull out? No, but we do notice there's a subtraction there, so I make that plus a negative. And I do 14x to the third plus 21x squared plus negative 2x minus 3.
Plus negative 2x.
I always keep the negative with the term, the third term to put in the parenthesis, so I always put it as plus a negative in there. Just so the problem actually works out. Okay, Emma, what is the GCF of 14x to the third plus 21x squared? X to the... And then what's left in the parentheses? So 3 minus 2 is 1. So that's just 2x plus what? Good. Justin Crater, what do I take out of that second parenthesis?
Don't you have to like switch it around or something?
We want the sign to be switched, so what do we have to multiply it by to make the sign switch? So we pull out a negative 1, which switches all of our signs. Because if we divide by a negative 1, it switches our signs. So we have the same thing here and the same thing here. Blaine, what is my final answer then?
2x plus 3
7x squared minus 1, yes. All right. I am going to get you guys your homework, and I want you guys to